Let's look at another constrained motion. Here we have 3 blocks which are kept on a smooth table and it's pushed by a force of 20 newtons. We need to calculate acceleration A5, A3, A2, acceleration of each block, and we need to figure out what the contact force between 5 and 3 and 3 and 2 are. Alright, so let's begin. This is also an example for constrained motion because there are just too many variables. Just think about it. There are 3 variables over here, there are 2 contact forces in between, so there are 5 variables, and we can only build 3 equations using Newton's laws of motion. So clearly there must be some constraints which we should be able to exploit. The constraint over here is the fact that all the 3 must accelerate together with exactly the same acceleration. So the constraint is A5 must be equal to A3 must be equal to A2. Why, you ask me? Well, the reason is quite simple. If the accelerations were different, for example, let's say the acceleration of block 2 was different than 3, then it has to have more acceleration than block 3, right? I mean, it can't have less, right? Anyways, the moment it gets more acceleration than block 3, it would break contact. And the moment it breaks contact, this guy enters uniform motion while this guy is still speeding up. So imagine that this guy breaks contact at 5 meters per second. Well, at that moment, this guy will also be at 5 meters per second. However, the moment it breaks contact, this guy will remain at 5 meters per second, but this guy will continue accelerating. So his speed will increase and it will bang him into this guy again. So you see, they can never break contact, because if they did, within nanosecond, it would come back and bang into it. So this is the argument that I'm going to use. So logically understand why this has to be true. Whenever the acceleration is the same, we can always treat the block as one big object, one continuous object. So what we will do is we're going to imagine this is like one big object. So we're going to treat it as an object of 5, 8, 10, an object of 10 kilograms, and assume that there's a force of 20 newtons acting this way. Now it's almost too simple, right? The acceleration is very easy to calculate. And that acceleration has to be net force divided by the mass. That's 20 divided by 10. That's 2 meters per second square. That's easy. So we found out A2 equals A3 equals A5 equals 2 meters per second squared. Okay, next we want to calculate the contact forces. How do I calculate the contact force? Now, for example, between 5 and 3. So for that, what I will do is I'll consider now the individual blocks. So let me draw forces on object number 5. Let's see what are the forces acting on him. Now there are some forces in the y direction, but they're gonna cancel out because there is no acceleration this way. So I don't care about the y directional forces. I only care about the x horizontal forces. There is a 20 Newton force acting this way, in this direction. Whether you put here or you put on this side, it really doesn't matter. So 20 Newton force acting this way, and the 5 is gonna bang into 3, therefore the 3 is gonna bang back into 5. So there's going to be a contact force, and this is the contact force between 3 and 5. I'm just gonna call it just F3 of 5. And together, because of the 2 forces, this block is gonna end up accelerating at 2 meters per second squared. So we can build Newton's second law equation for this. I'm going to take right side as positive. So 20 minus F3, 5, that's the contact force, must be equal to 5 to 2, that is 10. So there we have it. The contact force which we need is going to be 20 minus 10, that's just 10 newtons. So there's a 10 Newton contact force between these two guys. Now let's calculate what's the contact force between these two guys. For that, so I calculate here for object phi. So what I'm going to do now, I'm going to consider for object 2. I'm going to consider mass 2. And the reason for that is because there's only one force acting on 2. That's the contact force. So if I put 2 here, the only force acting on 2 is the contact force, which is F(2)3. And it's accelerating this way at 2 meters per second square. So that's almost too easy. It is 2 times 2, 4 newtons. Now you could say, well, gee, we did not use this guy. 3 kilograms. What would happen if I use 3 kilograms? Would I end up with the same answer? Well, I leave that as an exercise to you. Think about how many forces are acting on this guy, and confirm that because of the because of the forces that are acting on this fellow, it ends up with an acceleration of 2 meters per second square. That's for you to do it, okay? So here was another constrained motion.